Hello everyone, my name is Mr. Soumitra Adak, Assistant Professor, Department of Electrical Engineering. Today I am going to discuss about induction regulator. First of all, what is induction regulator? An induction regulator enables a smooth variation of output voltage. The output voltage is controlled by varying the angle between magnetic axis of primary and secondary winding. Next, the winding arrangement of single phase induction regulator. The primary winding placed in the rotor slot. It has to carry smaller current and smaller conductor area. No slip ring required because rotor movement is restricted from 0 degree to 180 degree, and flexible leads are sufficient to feed the power to the primary. The secondary winding connected in series with the outgoing line is housed in stator slot due to large conductor area. The rotor also carries a short-circuited compensated winding. It consists a vertical rotor shaft. Since the rotor does not rotate continuously, the induction voltage regulator in large size may be immersed in oil for cooling purpose. A hand wheel through rack and pinion arrangement control the rotor movement and therefore the output voltage. For automatic voltage control, the rotor movement is carried out by small diving motor and voltage relay sensitive to the output voltage variation. Now the working principle. When primary and secondary winding axes coincide, the maximum magnetic coupling between them and zero magnetic coupling with the compensating winding. As a result, EMF E2 induced in the secondary winding is maximum and rotor output voltage is V1 plus E2. If primary winding is rotated through 180 degree, the secondary winding is again maximum but polarity is reverse, so that the output voltage is V1 minus E2. The compensated winding is not affected by the primary winding at now because they are in quadrature. Consider the rotor suppose rotate clockwise through an angle theta. The magnitude of secondary voltage at now E2 cos of theta and output voltage is V1 plus E2 cos theta. When theta made 90 degree, the EMF induced in the secondary is 0. The secondary winding carry the load current I2. If there is no compensating winding, then secondary winding MMF I2 N2 would not be neutralized by any other MMF. As a result, MMF I2 N2 saturate the magnetic path and the reactance offered by the secondary winding is quite large, so that the output voltage across the secondary winding is very high. That's why placing the compensating winding. So when theta is 90 degree, the compensating winding and the secondary winding have maximum mutual coupling, so that secondary current I2 induce maximum compensating winding with the help of the transformer action. Now the MMF I2N2 is almost completely neutralized by the compensating winding, and reactance offered by the secondary winding is very small. Again, beyond the angle theta 90 degree, the mutual coupling is decreases, and eventually it should zero at an angle theta equal to 180 degree. Here in this graph you saw that the effect of rotor movement on the output voltage. Now the advantage and disadvantage of the induction regulator. The advantage of induction regulator is smooth output voltage control, and there is no interruption in supply circuit. The disadvantage of induction regulator is it is more initial cost, and due to the presence of the air gap, the magnetizing current is very high. Here I discuss the single phase induction regulator. Practically there should two types of induction regulator. One is single phase induction regulator, another is three phase induction regulator. So thank you everyone. If you have any query, please write in the comment box. Thank you.